The one thing what I can do is in the input, in the examples, if I go over, right, so x equal to 7 and n is equal to 3. So there is a number for which that number raised to the power 3 to be equal to 7. So I can start with number 1, then go on. So from 1 will be 1 will be less, I mean 1 cube will be less than 7. So it has to be more than 1. Then I'll go to the next digit, that is 2. The 2 power 3 is 8, which is greater than 7, the x. So it has to lie between these two numbers.
Yeah.
So, and then from then on, I can go maybe into a binary search.
Yep.
I can take the middle value and then again to compare. Then again take the middle value and then compare.
Exactly. Yes.
Okay. Let me try. Okay. I was going over that link. They had mentioned a lot of.
Yeah.
Okay. Let me try. So when we want to raise a number to a power n, right? Can I use the math function?
Yeah, sure, if you want to. I don't know if it says anything in the problem statement about that. I'm not sure. I think you can. Yeah, it doesn't say anything not to use it, right?
Okay.
Oh no, it says it right in the first sentence. My bad.
It says.
It says without using any standard library functions.
Okay.
I guess if you're gonna implement it anyway, you could just use it if you want to. Like I don't really care. I just didn't know if you wanted to like stick to it or not.
Okay.
This is definitely on the right track. Yeah, I mean, this looks pretty good. I think it might work.
Okay. Only thing now I'm checking is it says ki, every time we have to see whether the the error has to be within the range of 0.001.
Yeah.
And I okay, and I should change it. The value is double, so I should change the return value to double.
Oh, yeah, that's kind of annoying. That sucks.
We can just go over the code once more and then
Yeah.
play it. I think here the value is right. I think here I should check whether it is in the range of 0.001.
Okay.
Okay.
It's
Okay.
looking pretty close to what they have. You definitely did it a little bit differently than the answer, but I mean, it could easily work. I see what you're doing.
Okay. Okay. So, what do you want me to do? Do you want me to do the run code, or we can just swap the code so that you can also continue with your problem?
If you want to, either way, dude. If you want to try the test, if you want to switch, like whatever.
I'll just see whether it compiles in the first place.
Hmm. Oh, it's like double stuff because you call like power because number is a 0 or an int, and then I guess it's calling power func on the integer, and then it gets a double or something like that, maybe.
Yeah, that's what I'm checking. So okay.
Maybe if we just make everything double, like it'll probably be fine, right?
Yeah.
Yeah, let's just do
Okay.
that.
There is a problem.
Let's try. I just made everything double. Let's see. What the heck? To enable test case evaluation. Oh, I guess they updated Pramp. I guess you have to approve me doing tests or something like that. I didn't even know how that works. It's like a new update where I can't run the tests. I'm not allowed to, I guess. Okay. What? Hmm.
Some double something.
I don't even know what this means. Oh, power func takes in two things, I guess. Right here.
Yeah. Yeah.
Gosh. Oh, it's the right here too, and right here. And then this one I think is I gotta fix this.
Just a second. Just a second.
Sorry, I was just
Just.
fixing my bad.
I'm just.
Oh, we're almost done now. think you just got to do the whatever return, something like that. For,
yeah, something like yeah. Yeah.
Okay, so it executes now.
Yeah.
Oh, we have to write our own test or something?
No, we can do the run test also. I mean, whether it passes whatever they have as their unit test cases. Okay. So you want me to run the test?
Sure. I mean, yeah, if you want to. If you don't want to, we can do whatever. I mean, if you want to know the solution, let me know what you want to do. I got the solution. We could do the test. We could do whatever.
Okay.
All right. 1.5. It looks like you're getting pretty close. It looks like you're getting the rounded number.
No, I got it. I got it. It has to be in that way.
Yeah. So you keep hitting 0.5 and then it looks like you stop.
Yeah. The first point only. But why did it? It should not even have gone to that case. The power of acting.
Oh, you know why? It's because of this, though.
Uh,
Because this is gonna. This kind of returns no matter what, it looks like.
uh,
Or maybe, right? Or. Think. All right. So I mean,
Let's.
I think you definitely had the right idea right away with the binary search. Um, like that's the optimal solution is the binary search. I'm gonna like
Mm,
show you the one that they had for the pseudocode. So it looks pretty
okay.
similar. They did a couple things differently, but I think you were on the right track for sure.
Okay. 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 Here it is. There is a power function here. Which is a power function?
They didn't. It's kind of like pseudocode, I
Oh,
guess.
okay. Okay. Fair enough. I think I'm pretty close. Yeah.
Yeah, it was pretty close for sure. But
Okay. Okay.
yeah, I mean, you got the binary search, so that's definitely. I think that's like the main takeaway is like the
Okay.
binary search. Um,
Perfect.
all right, cool. So let's do
Yeah.
switch
Let's
thing.
grab the rules. Yeah.
All right, sweet. All right, let's see. Given an array of integers array where each element is at most k places away from sorted position, code an efficient function sort k mess array that sorts the array. For instance, an input of size 10 and k is 2. An element belongs at index 6, and the sorted array will be located at 4, 5, 6, 7, or 8 because it can be within 2 spaces away. Or in the input array, analyze time and space. Okay. So any number is at least is k spaces away. It can be k spaces away from where it should be.
Yes. Yes.
Um,
It can either be k places away or k places behind.
okay. Um, So my job is to sort this, I guess. Right? Yeah, I'm sorting it, right?
Mm.
Okay. So my first instinct is I could do the brute force, which is like a double for loop, which is like insertion
Mm-hmm.
sort. That's like a regular sorting algorithm that I could do, but that's not optimal, right? That's like n squared. Um,
Mm-hmm. Yeah.
so what is the optimal time of this? I could do merge sort, and that's log of
Mm-hmm.
n. I mean n log n. Sorry,
Mm-hmm.
n log n, not log of n. N log n.
Right.
Um,
Right.
so I would say that's probably not optimal here because I would just do that, and they probably don't want that. So I don't think that's optimal. So better than n
When
log n would be
when do you think it would be optimal?
probably would have to be linear because merge sort's already n log n, so it's got to be linear, I guess.
What I'm asking is, let's say if you do a sorting of the array, I mean, in which case it it might be okay. Yeah, it's not an optimal solution, but in which case will it be okay? I mean,
For
just
merge
give it
sort,
a yeah, n log n.
um, I would probably say almost any case I would use when I have a lot of space I would use merge sort because it uses space, but I would use quick sort if I didn't have space because quick sort doesn't use extra space.
Let's assume you do have space.
Well, then I could use merge sort, but I think that that's too easy of a solution, I guess, because I could write merge sort right now, but I think they
Mm-hmm.
want something better than that is what I'm guessing because I think that would be too easy because they give it like harder stuff.
Okay, okay. In case you are short on space and you can't have, let's say, and I mean, you would need to have an auxiliary array, right, in the merge sort. So you let's assume you do
Yeah,
not have that much of space. You have a bit lesser space.
sure.
Space is there, but lesser space.
Okay, so I'm gonna say I have temp arrays equal to new.
Hang on a minute.
Yeah, yeah.
Hang on a minute. I'm saying okay, merge sort of quick sort of what this thing right. it will do a sorting of the complete array.
Sure.
Right? What do you want to do? You want to do a complete array, or can you make use of this k meshed array sort? There's a value k over here. If we make use of this n log n thing, it is not making use of the k, isn't it?
Yeah, that's what I'm saying for sure. Yeah, so that's not
Yeah.
optimal.
Can you think of on those lines? I mean, where you can
Using the k. Yeah, so I guess what I'm thinking is, first of all, if it's not, wait, let me think about this. The numbers are at their index if they're in place, right? So 1 is at position 1 if it's in the right place. So yeah, okay. So what I'm thinking is, if I'll know if I loop through in a linear scan, I'll know which ones are in the right place for sure. Like if I see 1 at position 1, that's definitely in the right spot. When I see something out of place, I need to.
Not really.
Huh?
I think are you making an assumption that the numbers belong from only from 1 to n? They can be 100, 200, 300, 400, 500, 600.
I'm just saying if like I know if the number's in the right index, if it's the same as
How
the.
would you know?
Because if I'm at like number 5 and if I'm at index 5, the number should be 5, right?
No, that's what I'm saying. Where is that assumption coming from?
Oh, that's what I thought it was. Hold on, wait. An element belonging at. I think that's what it says, right? Isn't it? That's what I thought.
It can be 100 to 105, total 6 elements. It just says that each element is at most k places away.
Yeah, no. What I'm saying is like, here, let me give you an example. Like, sorry. So let's say that we have, 15, or it can be any number of elements, right? Yeah, it could be 11, 12, 14, 13, 15, 16, right? So here's like, that's a good one, right?
Yeah.
I know that this number should be 1, like right here should be 1 because it's index 1, right? So that's what I'm saying. That's what I'm working on right now, is like I know that at the index is where the number should be, but it's not. It's a 4.
I'll give you one example here. So let's keep it only for, let's say. How about this?
That's I did not think that was like a thing. I didn't know that was possible. Okay, so I didn't know that. I thought that it was just like the number had to be at the index. Okay, so that actually makes it harder. Okay, but I don't understand how it could be like this, because then how would I know? Are you sure it could do that?
See the number 50 in the example that I gave you, right?
Wait, let me.
Number 50 should be at 5th place.
Right? Yeah. Let me just.
50 should be at 5th place. Currently, it is at 3rd place.
Yeah, right? But
when. 50, right?
Yeah, I know what you're saying. Let me just run these and make sure, because I don't know. That seems like way harder. Can I like see the test cases? How do I return this? Return temporary. Like that looks fine to me.
What is it saying? It can't be converted to int.
It's not an int. What do you? Okay. Oh, no. Sorry, that was it. Yeah, that's right. My bad. What is this? Oh, array dimension. Okay.
Array dimension missing.
God. So the first one is 1. Let me look at some of these test cases.
Can you can you can you think of some place where you can maybe?
But all of their test cases aren't saying that. Is what I'm looking at.
No, they're saying right. First case is where you have got only single element. Now you are Now you are creating a new array. You are returning an array with maybe some junk value, right? I mean, what value will it contain? So that will definitely not match. You are passing some app, and you are returning some values which are not initialized.
Yeah, but like this, I don't think this is like a scenario. I think they have to be like index 0. There can only be the elements in the array can only be like k away or whatever. Like I don't know, you know what I mean?
No,
They have to be in their
okay.
index.
Tell me one thing. Let's assume if that assumption is right, then do you really require this k image array sort and all that? Do you really? Let's assume. Let's take that question first. If the let's assume that the numbers are from 1 to n.
Yeah.
And they are at most 3 places away. How would you go about it? Just this we can discuss the solution. How would you sort them?
If what I'm saying is what I thought, what the index is and stuff.
Mm-hmm.
Yeah, I think okay.
How would you go about it?
I think I would do like a linear scan, and I would just put the numbers into a new array at their index or something like that.
Do you really require to allocate a new array for this, given the knowledge that the numbers are only from 1 to n?
No, then you could do swaps, probably.
Okay. How would you do that?
I'd have to think about that for a second.
In a single pass of the array?
Maybe. If you... Let me think. If I see a 1 at position 0, then I want to swap it with position 1. Then I just... If I have pointers, maybe I have 2 pointers, and I loop through, and one of them just keeps going. No, that's unsquared. I have no idea. If I go at the beginning and if I see a 1 and then I go to 0, 1, and then I swap, but I'm gonna No, that is fine. No, that's unsquared.
That will be selection sort, right? That will be n squared.
Yeah,
right?
Yeah. Maybe if I start at the end and I go towards the middle I meet them in the middle or something.
Right. No. So one thing we can come back to that. We can come back to this question, what I just asked you later.
Sure.
But however, in this question, the assumption that you are making the index and the value should match, that's not right. The only thing it says, after sorting, if they compare the spaces, right, and if they compare the indices, then there would be at most k places away, either k places ahead or k places behind. Like in the example 10, 40, 50, 20, 30, 50 is 2 places away from its place. That right now 30 is sitting. 20 is 2 places away, 30 is also at most 2 places away. 40 is also 2 places away. Can you think of something where maybe we can store these k values?
Oh, maybe it's like a sliding window thing or something?
Yeah, maybe. Yeah.
So like you have a group of k elements as you go through a linear scan, and so like
you would still need to have an order between those k elements, isn't it? Because ultimately you have to push those elements into their correct places. So can you think of a structure? Can you think of a data structure which is sorted, or inherently? Or if you get some element out of it, it will always be sorted.
Wait, no, maybe not. I mean, I don't know. Heap?
Yeah, go on.
Heap? This is a heap thing?
Right.
This is a heap problem?
Yeah.
What the heck?
Yeah.
Okay. I'm not that good at heaps, so. Okay, so if you have a heap.
No worries. Mm-hmm. Just explain to me the idea.
Okay. Heaps, okay, so there's like min heaps and max heaps. I remember
Mm-hmm.
that. And then. Okay, so yeah, okay. No. Okay, wait, if you have like a window, if k is 2, then you put them
Mm-hmm.
into a heap of size 2, and then you know where the
Mm-hmm.
you pop the max off, that goes into the max. But if it's 3,
The
then
min
you
heap.
have the max, but I don't know how you get.
So
Wait.
take this example. You have k is equal to you have k is equal to 2 and n is equal to 10, right?
Yeah. Yeah, sure.
Okay. Okay. So let's say 2 is a very small number. Let's say k is equal to 5 and n is equal to 10. Okay. So at max you are allocating big of k space.
That's true. Yeah,
If
that's
you need,
true.
right, right. Now, if you have a min heap of size k, the topmost element or the when you do a when you do a pop of that element, that will give you the lowest element, right?
Oh, okay, wait, I
Of
think
all
I get
those
it. I
k
think I
elements.
get it. Because you're going,
Yeah.
you
Can you?
take it and you go through the array and you keep adding the next element into the heap and popping the minimum element out of the heap. Oh,
Yeah.
all right,
Yeah.
okay. That's pretty
Now
good.
just
That's pretty good. I would have literally never thought of that though. Like I'm not good at like heap things, so that would have taken me like forever to figure out.
no, that's okay. That's okay. Just can just complete it. I mean, say, starting from okay, how can just complete that algorithm from start to end.
So
You will have a
I'll initialize the heap with the first k elements, and
okay.
then I'll take the minimum and I'll put it into the first part of the array, and then when I then I'll pop that pops off. I go to the next element and I put it into the heap, and then I repeat that process all the way to the end of it. And then oh wait no, and then at the very end you have to do like the last 3 outside of the loop.
Last
I
k
think.
element. Last k elements. I mean, whatever the k elements are there in the heap, they again need to be popped and added. I mean, put into the array again.
So you just pop the last 3 at the loop
Yeah,
ends, and then you
last
just
k elements.
yeah, and then you just pop, or k amount of pops, and then you just
Yes.
put them on the end of the array.
Yes. 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 Yes.
Okay.
So, what would be the complexity of this if we do that? The space complexity and the computational
Okay.
complexity.
So space is k. We already talked
Mm-hmm.
about that.
Mm-hmm.
Linear scan n times k. Um, wait, wait.
Come back.
You
Linear
have
scan how much?
a heap is actually wait. A heap's like a tree. So I think a heap. Is heap like log pop or something like that? I think it's logarithmic pop or something. Okay, so if it's logarithmic pop, then I think it's wait n log k.
What
N log k
what is the pop? What is the complexity of the pop option for a min heap?
log of k, or maybe right.
Is it?
I think I'm not 100% sure.
It's a min heap, right? It's a min heap. So if the
Is it
what would be the
constant?
top limit of the tree?
Yeah,
If it's a
because it's just constant because it's just the root.
if it's a min heap, we are guaranteed to have the minimum element among all of those to be at the top, the root.
Yeah, but
So I
when
can just
I thought with a heap, like you pop something and then you have to do like this like traversal and push some other stuff back up or something like that.
correct.
So
So how much
log,
is that?
is that logarithmic?
That is logarithmic. Yeah, log of the size of the height of the tree.
Okay.
total number of elements basically. So log k, right?
And log k.
Yeah, and log k. Yeah.
Okay. Sweet.
So instead of log n, where let's say n is thousands
Yeah,
and
yeah,
k
I
is
see what
let's
you're
say
saying.
only 10. So 1000 log 1000 is way more than 1000 log 10. So that's where
100%.
we
That
are.
makes way more sense.
Yeah. If k is almost equal to n, then we don't need to do this. Then we can go for a simple merge sort or quick sort or something like that. If
Oh,
k and
yeah.
n are almost equal, because I mean at that scale you won't save too much of the power.
Yeah. Yep.
Yeah.
Yeah, I understand
And this,
completely.
and in that case, that space of O of k, if k is almost of the order of n,
Yeah.
then there's no. It's like a merge sort only. It's an auxiliary array if we take this approach, this
Mm-hmm.
heap approach.
100%. All right, cool.
Yeah.
I mean, that was
Okay.
interesting for sure.
Okay.
Would it be okay if you like pasted the solution before we get off, or do you want me to code it or something like that, or just so I could show anyone on YouTube or whatever
Okay.
when
Yeah. Wait a second. I'll do that. Yeah. Here it is.
All right. Just let it sit. So you got the array, you got the heap, you build the original heap, you loop through the array. Exactly. Yeah, exactly what we said. And then at the end, you got to do that extra k uh, thing, and then put the last parts in the end. Okay. Awesome. Well, I mean, that
Okay.
was pretty good. Definitely got to get a little bit better at heaps because that was like the last like thought in my mind was a heap. I was like, I don't know what the heck. Because I was like, how the heck is it possible to even do it better? But yeah, that makes sense.
Yeah. When, yeah. When you are stuck like this, right? Initially, you should start off with the brute force solution, which you already gave. You said, okay, will do a sorting, right? Then then you should be looking for the hints from the interviewer. I mean, if
Yeah.
the interviewer is asking you, okay, can you think of a data structure with k value? The moment you hear k or something, right, then it should tell you, okay, maybe we need to copy these elements either to an array, an auxiliary array just for k elements, or something of that sort. That should ring the bell
Yeah.
for you. Yeah, and yeah, it's pretty much.
Yeah.
That's pretty much.
All right.
Okay.
Well, cool.
Okay.
It was nice, working with you.
Yeah.
I don't know what you're interviewing for, but I hope you get your, software engineering position or whatever the heck, you're interviewing for. But
You too.
yeah,
You
really
too.
good. So,
Yeah.
all right, dude. I'll see you later. Good luck with
Okay.
everything.
See you.
Nice
Yeah.
seeing you.
Bye bye.
All right. See ya. Okay, yep, let's give that guy all fives. Maybe I'll edit this one because there was a little bit of a pause in the beginning. I asked him if he was comfortable with me putting this on YouTube, and he said yes. Instead of doing I think in the last one it was kind of weird for me because I was like, look at this, look what I'm writing. I didn't even notice. I'm just like, I don't care. Great communication. Nice guy. Nice guy. Not much. Just more practice. Great job. Freaking hard. I didn't mean to do that. Good. Whatever. Okay. So yeah, like I was saying, what was I saying? I'm sorry. What was I saying? Dude, I don't remember. But yeah, that guy was nice. But what I didn't want to do is start the video before I actually asked them for their permission, like I did in the last one. I think that's weird, and it made me feel awkward. So this time I asked him for permission, and then I started recording. But very nice guy. I thought he was a good dude, and I'm not up to date on heaps, obviously, but yeah, that was interesting. And the binary search with the whatever that was, there was a little bit, I think mine was more talking. I don't like to bother people. I like to kind of go along with their vibe or whatever, but I might edit that because he kind of, there's obviously differences between programmers. I'm more of a animated person. He seemed to be very focused and want to do the problem, so I'm just gonna probably maybe edit. Either you'll know by now if I edit it or not, but I think I might cut out any chunks of silence just to make these a little more concise. But overall, that dude was good. The last girl that I did this with was good, and I'll probably do a bunch more. So let me know what you guys think. That's this isn't. I'm not doing these to make myself look good. Obviously, if I was doing that, I wouldn't have messed up a lot. Or I would just record a new one. But that's realistic. Heaps. I'm not up to date. I would never think of heaps. But and that time complexity difference is a little bit more subtle than a log of n compared to linear compared to n squared. It was n log n compared to n log k, and he was explaining if you listen to what he was saying, the k and the n are the big difference there. If n and k are similar, you might not want to do that approach, but in some cases that was a good algorithm. So thank you guys for watching. Hope you guys like these videos. Once again, shout out to Pramp, not a sponsor, but I think they're great. And also, please go to my Patreon. I'm making these study guides for people based on me passing Uber and Google finally. I want to make study guides I'm going to get specific questions from LeetCode and HackerRank and put days, like day 1, day 2, day 3, or whatever, and put these questions in the study guide, the questions I think you should do in order, so maybe I'll do a binary search first, and then an intro linked list. I'm gonna pick my questions that I did that I think will really help mold your understanding and make daily guides for them. So thank you guys for watching. Please subscribe and like or whatever, and yeah, that's it. See ya.